welcome to a video tutorial working with word problems and money and interest. I've got more of a difficult word problem here for you involving simple interest formula. So let's put this out. We've got interest rate problem, simple interest. A lot of times we use the formula interest equals your principal, how much money you put in, times the rate, what's your interest rate that you're getting in terms of percent, times time, how many years are you putting it in for. So then again, labeling it out, we've got interest equals principal times the rate, R, times time. Okay, let's read this problem and see how we can use that formula to solve it out. You inherited $9,000 and decided to invest it in a couple of different accounts. In one account, you invested part of the $9,000 and things did really well as it grew at an interest rate of 11%. Unfortunately, the other part of the $9,000 you invested in an account that suffered a 4.5% loss. Ouch. Altogether, however, you still made $648.58 in interest that year. Determine how much you initially invested in each account. All right, so let's start making kind of a diagram. Again, the hard part of word problems is taking all this gigantic paragraph of stuff and figuring out how to write an equation and get somewhere with it. So here's what I like to do. Start off with, we've got $9,000. All right, what do I know about my $9,000? I put part of it here in an account I'm going to call account A, and I put the rest of it in an account I'm going to call account B, just for now. In my account A, I'm going to make that the one that grew 11%. I'm going to make B the one that lost 4.5%. And reading carefully, it was all over a 1 year period. So that makes it really easy. So for time, I'm just going to put 1 in here. Not even worry about time, just 1 year, put 1 in for T. That makes it really simple. Okay, so I need to use some variables. I need to use some algebra. And that's what actually makes this part of the problem tricky. I have two things that I don't know, right? I don't know how much money I put in A, and I don't know how much money I put in B. The only thing I know that is it totals 9,000. So the strategy you want to do is just pick one. I'm going to make my unknown variable X the amount of money I put in for account A. I'm just going to call it X. So X is the money in account A, the one that grew. Well, what that leaves then is if $9,000, if X amount of that is put in A, then what do I have left? Well, I have $9,000 minus the amount in A. So I have to write an expression for the amount in B. So 9,000 minus X equals the money in account B. Hopefully that makes sense. Again, if I add these together, 9,000 minus X plus X is going to add up to $9,000. So it works out, but that's kind of your strategy. I need one variable that I get an equation with so I can use that one variable, however, to represent the money in A and the money in B. All right, so now I need to use this $648. I know stuff totals there. So let's kind of think about what we have going on here. So we have the interest I made in account A. So the interest in account A, I'm going to label it with a little a there, plus the interest from account B, even though it lost some money. However, they totaled up to, if I add what happened in both accounts, if I take the net effect is that I combine them and I get $648.58. All right, that's going to be helpful now because I know the interest is related to, or it's equal to, principal times rate times time, and I've got some rates and I've got some principal for both of my accounts. So I'm going to substitute that in here. So here we go. In interest for account A, we invested X number of dollars. and it grew by 11%. So I'm going to use the decimal, so I'm going to put 0.11. That's 11%. So 11% of X would be the amount of interest I earned for account A. Now, for account B, we lost 4.5%. So I'm going to put a negative, I'm going to put by principal here, 9,000 minus X. I'm going to put that it lost a negative 0.045%. So the net effect account A, the interest, plus the interest in account B equals 648.58. Running out of room. Nuts. Hopefully, I'm sure you never have that problem in your paper. All right, there we go. We got an equation, right? The interest from one account plus the interest from the other account totaled that. We used our variables. We put together something. I hope that makes sense. How we used X and defined X. We have a little chart that helps make sense of everything. Let's solve this guy out now. All right. So let's rewrite it in a little bit friendlier sense over here. So we have 0.11x plus negative 0.045 times 9,000 minus x is equal to 648.858. First thing I'm going to do is distribute. I'm going to multiply that negative 0.045 and simplify, move some parentheses. Now we get 0.11x. I get minus 405. And then I get plus a negative times a negative. I get plus 0.045x is equal to 648.58. All right, that looks a little bit nicer now. Let's combine some like terms here. We've got like terms with my x's. I'm going to combine those, and I'm also going to add 405 to both sides to kind of move things over. So what that gives me now is I got 0.155x is equal to $1,053.58. So we're slowly working our way. We're doing all the algebra stuff, right? Slowly trying to figure out what does x equal. All right, my last step to get x, I got to divide by the decimal in front of x, 0.155. And when I do that, we find that x equals $6,797.29. Okay, I've solved it. I've done all my algebra, but algebra as a means to end, I still got to figure out the question, which was determine how much you initially invested in each account. Don't forget to fully answer that question. So what we've got is x is this number, and I've defined x to be the number, the money in account A, which is the one that grew. So we invested this much, 67.97.29, in the 11% growth account. And to find what I put in the other one, I subtract 9,000. I take that from 9,000, right? So if I subtract that from 9,000, we see that we invested $2,202.71 in the 4.5% loss account. Okay, so that's a pretty hefty problem, right? A lot of going on there, a lot of translating, a lot of defining variables, using this interest formula, but having two different accounts to keep track of. Hopefully that's a good example for you as you're working on your own money and interest problems and gives you some ideas about where to get started.